All right, lesson 5.2 is all about angles, arcs, and chords. So first off, a central angle is an angle whose vertex is at the center of a circle. We call the unknown angle theta. We just use the Greek letter theta. You can always draw it as a circle and just put a line across it. If you ever see a question that says find theta, they're asking find the measure of this angle. So the congruent triangle theorem says that two circles are congruent if and only if their radii, that word radii is the plural of radius, so two or more radiuses are called radii. So the two triangles are only congruent if the radius is the same, if the radii are congruent. So example, true or false, justify your answer. The circles at right are congruent because their central angles are congruent. For both of these circles, so this angle and this big angle here, they're actually the same angle. Okay, we can measure that out. It's going to be the same angle for either one. So does that mean that the two circles are the exact same? Well, look at this larger circle, this red one. A little bit off there. Tap it down. And let's do the other one in blue. Oops, I wanted to... Oh, it changed the whole thing. Alright, we'll do blue and black. Live with that. Maybe I can change this. There we go, blue and red. Obviously we can see these circles are not the exact same. This blue one is much larger than the red one. So just because that central angle is the same, the radiuses, or the radii, are not. This red one, the radius is only that far, and for the blue one, the radius is this far. So obviously one of those, the radius is longer than the radius of the other. So no, these are not congruent, false. Because the radius is not, the radii are not congruent, these would not be congruent circles. Let's move on to a couple more terms. An arc is a portion of the circle's circumference. It's a curved segment around the outside of a circle, and we use the points to write the arc name. So I'm going to draw 2 points on here. 1 point here, 1 point here. We'll call that A. We'll call that B. Okay, so there's a couple kinds of arcs we can look at. A major arc is an arc that measures more than 180 degrees, and you always measure it as the central angle. So if we were going to go all the way around the outside this way, from A to B, that would be called the major arc. That was the one in red. A to B goes all the way around the outside. The minor arc, AB, would be an arc that measures less than 180 degrees. So if we were to go right like this, that would be the minor arc. Okay, so if I were to use purple, if I were to draw the central angle right here, and this angle we'll say is 60 degrees, then this blue one from A to B would be a 60-degree arc. It would be a minor arc because it's less than 180 degrees. On the outside, though, this big angle going this way is going to be 300 degrees. Okay, so this from A all the way around the outside to B would be a 300-degree arc. It would be a lot bigger than 180 degrees, so that would be the major arc. A semicircle, then, is half of a circle. It's formed by a 180-degree arc in the diameter. So if I were to take diameter just like this, those endpoints then, let's draw this one in green, here all the way around the outside, that would make a semicircle. Okay, it's an arc that is exactly 180 degrees, and the diameter then, half of a circle. The arc measure then is the degree measure of an arc that is found from the central angle that would form the arc. So just like we did here, this central angle was 60 degrees, so this blue AB, this arc measure is 60 degrees. The red one, AB, all along the outside. If I move this green thing aside, this red arc measure would be 300 degrees. Okay, and then this semicircle degrees, or the arc measure, would be 180 exactly. So let's look at some examples. Given circle Y, right here, we name it from its center. We need to find angle AYC. So A to Y to C. Well, any circle has 360 degrees. This one is a 90-degree angle. This is 110, and this is our missing. So 90 plus 110 plus this angle would be 360. That's set up right here. Combine our 110 and 90, and that'll be 200. Subtract 200 from both sides. So AYC is 160 degrees. Okay, so now we have each of these central angles made up. Now they want to know arc measure of AB. So that's, again, going from A all around the outside. But I'm going a little on the inside, A to B like that. Okay, well, that one is going to be this 110 degrees. So it would be a minor arc. It's less than 180 degrees, so this one is going to be a minor arc. A to C. A to C again is this one on the outside. Just going A around to C. Well, that one is going to be 160 degrees, so it is also a minor arc. It's less than 180. A to B to C. Notice how we go A, B in the middle, C, which means we have to go from A all the way to B. We take the shortest distance there, and then we have to continue on to C. So we had to go all the way around it. So that would be this piece, 110, and this one, 90. So it's 200 degrees all the way around. So this one would be a major arc because it's more than 200 degrees, or more than 180 degrees. Comes all the way around. And the last one then, ACB. Let's draw that one in real quick. A all the way around, oops, to C, all the way around to B. That'd be this piece, the 160 plus the 90. So that one would be 160 plus 90 is 250. So it is also a major arc. Comes all the way around the outside there. Example 2. When we're looking at this circle, we need to find x. Now, the angle rules still apply. So by vertical angles, this angle right here and this angle right here, because they're on the same two straight lines, these angles are going to be the exact same. So I can take this 5x plus 5, put it right in there. So now we know a measure for each of these angles. So the whole circle is 360 degrees. So by the parts to whole theorem, we would just add everything up. It would have to be 360, so we added up each of these little pieces. Combining our like terms, 20x plus 5x plus 13x plus 8x plus 5x is going to be 51x, and 5 minus 3 minus 4 plus 5 is going to be plus 3. Subtract 3 from both sides, we get 51x equals 357. Divide by 51 and we get x equals 7. So that'll be our final answer for this one. Oops. This way. Arc addition. Measure of an arc made up of two smaller arcs is the sum of the two arcs. We kind of already did this a little bit. We basically just said we can add up like A to B and B to C, like that, and that would make our new arc ABC. One whole big arc. So before we go ahead and start finding all these arcs, let's finish out the rest of these. Let's find what the rest of these would be. If this is 90, that means this one has to be 90 in total, and this piece is 25. So 90 minus 25, this one has to be 65. Again, like before, because of vertical angles, this one would be the same as this one. They're on the same two lines. So this is also 65. And if this is one straight line, this blue one across, and this piece of it is 65 degrees, the whole thing has to be 185, and this has to be 115. Okay, so we have each of the, I suppose I can write this in to help us, 90. So now we know the measures of each of these central angles. Okay, there are 5 of them. So what is the arc measure of AC? So going from A all the way to C this way. Well, that would be 25 plus 90. I can write that in. Which is going to be 115. So that would be the arc measure of AC. What's the arc measure of A to E? Okay, that would just be from here to here. Well, we already found the central angle. It would be 65. What's the arc measure of AEC? So that's, let's do this in purple. A to E and all the way back around to C. So we have to add all of these, 65, 115, and 65. Luckily, we know that these two already would be a straight line, so those are 180 together. So we just need to do 180 plus 65. Which is going to come out to 245. So AEC would be 245. Arc length, the length of the curved arc segment. So in this case, it would be if we were going to take a string and hold it across this edge here, and then put that string back on a ruler and try to measure that length. How long would that string be? Okay, the formula for it is right here. We use that measure theta, so this piece right here, multiply it by pi over 180, and we multiply it by the radius, so this one right here. Okay, so theta times pi over 180, all of that times the radius. So let's try an example with that one. In this case, our theta is 30 degrees, so we put that right here. Our radius is 6, so we put that right here. So we have 30 times pi over 80 times 6. 30 times pi over 180 becomes 30 pi over 180 times 6. 30 over 180, we can cancel out a 30 from top and on bottom, and we would just get pi over 6, because 30 goes into 180 6 times. So we have pi divided by 6 times 6. Well, these 6's will cancel out, dividing by 6 and then times 6, which means the length of this segment is pi, I guess if that was centimeters, we call it pi centimeters long, or 3.14 units long. Let's do one more example of the arc length. We want to know the arc length of W to Z. So this length right here. In this case, this diameter goes all the way across, is 30. Again, we don't know if it's centimeters or inches, just 30 units, which means that the radius, if we were going to cut this in half, this radius would be 15. So remember, we want to use the radius, not the diameter. So first find out that our radius is 15. Then plug it into that formula. Our theta, our angle here is 46. So that goes right here, 46 times pi over 180 times 15, that's our radius. So then we would say, get rid of this, 46 pi over 180 times 15, because we just multiplied this and this. Simplifying all of this down, 46 times 15 becomes 690, so we have 690 times pi over 180. On this one, it might be easier just to multiply everything onto your numerator first and then divide it by that denominator. So when we do that, we can simplify it down to either 23 over 6 times pi, and we can leave it in terms of pi, that's okay. Or, if you want to find more of an exact answer, it would come out to approximately 12.04. So this length here is about 12.04. We will call it good for our first video then.